We'll give more examples on solving exact differential equations. So the first problem in this session is to solve 3x squared plus 4xy plus 2x squared plus 2y dy dx equals to 0. Now the first step is to arrange the equation in the form m dx plus n dy equals to 0. So if we multiply through by dx, we still will have 3x squared plus 4xy dx plus 2x squared plus 2y dy equals to 0. So m will be 3x squared plus 4xy. N will be 2x squared plus 2y. So we test whether partial m partial y is partial n partial x. Now, if this is m partial y will be 4x, and if this is n partial x will give us 4x. Second term will be 0 because there's no x. So clearly, partial m partial x partial y, which is 4x, is the same as partial n partial x. So that means that the equation is exact. So which implies the equation is exact. So there exists a function f of xy such that m dx plus n dy equals to partial f partial x dx plus partial f partial y dy. So the key thing is to find this function f. Now m is given by 3x squared plus 4xy, so which is the same as partial f partial x, so I call it equation 1. N is given by 2x squared plus 2y, which is now partial f partial y, call it equation 2. Now we integrate equation 1 with respect to x to get f, i.e. f of xy equals to the integral of 3x squared plus 4xy dx. So integrating this term, we get x power 3. This next term, we get 2x squared y plus a constant, but that constant, we write it as a function of y. So call it equation 3. Now, again, differentiate. Equation 3 with respect to y, we get partial f partial y is equals to, this will be 0 because there's no y. So this next will be 2x squared and then plus g prime of y. Call this equation 4. So remember, what happens in the process of solving this exact differential equations is simply the process of integration differentiation. So those two are the main techniques that are being applied here. Now, 4 and 2 are the same because they define partial f partial y. So we can say from equation 2, we have 2x squared plus 2y equals to equation 4, which is 2x squared plus g prime of y. Now, common terms cancels out. So this and this cancels out. So g prime of y equals to 2y. So call this equation 5. Now to get a function g, we now have to integrate equation 5 with respect to y. Integrating equation 5 with respect to y, we get, so this will give us the function g of y, integral of 2y dy, and this will just be y squared. So remember, at this process, you don't have to add a constant of integration. It will be taken care of in the final structure of the answer, which is f equals to c. So g of y equals to y squared, and let me call this one equation 6. So then just replace 6 in 3 to get f of xy equals to equation 3, the first term is x cubed plus 2x squared y plus g of y whose value is y squared. Now this simplistic solution is f of x, y equals to c. So, which implies we have f of x, y equals to c will mean x cubed plus 2x squared y plus y squared equals to c. So that is the answer to that given differential equation. More example. Solve 2x sine of y dx plus x squared cos y minus 1 dy equals to 0, subject to y at 0 is a half. So this is an initial value problem. In this case, we see that the equation is of the form m dx plus n dy equals to 0. So m is 2x sine of y, and n is x squared cos y minus 1. So the test is partial m partial y is partial n partial x. So from m partial y is going to give us 2x cosine of y, and partial n partial x will be 2x cosine of y. So clearly, partial partial y equals to 2x cos of y, which is partial n partial x. So, which means that the equation is exact. So there exists a function f of xy such that m dx plus n dy can always be written as partial f partial x dx plus partial f partial y dy. And the interest will be now to find this function f. So m, which is partial f partial x, in this question is given by 2x sine of y. You call this equation 1. N is partial f partial y, which is given by x squared cos y minus 1. So call this equation 2. So we can get f from either 1 or 2 by integration. So integrating equation 1 with respect to x we get. So remember, when you integrate the left-hand side, I get the function itself. So I'll have f of xy with the integral of 2x sine of y dx, which will be f of xy. So with respect to x, I get x squared sine of y plus a constant, which will be written as a function of y, g of y. You call that equation 3. Now, again, differentiate this new function. This time round with respect to y, to get partial f partial y. So it'll be x squared cos of y plus g prime of y. All this 4. Now 4 and 2 define partial f partial y, so they're the same. Equation 4 equals to equation 2. All of them define partial f partial y. So that means I take equation 4, I equate to equation 2, which is x squared cosine of y minus 1. In this equation, some terms cancels out. So this and this cancels out. So we have g prime of y equals to -1. So let me call this equation 5. To get g of y, we integrate 5 with respect to y. Integrate equation 5 with respect to y to get g of y, i.e. g of y will be the integral of -1 dy, which will be negative y. So we don't have to add the constant of integration. It will be taken care of when we're writing our general solution. So g of y equals to minus y. I call this 6. So what we do now, we replace 6 in 3 to get now the f of xy. So we'll have f of xy equals to equation 3, x squared sine y plus g of y, which is minus y. So solution is of the form, so general solution is of the form f of xy equals to c. So in this case, we'll have x squared sine of y minus y equals to c. So this is what we call the general solution of the equation. But now we were given extra information that y at 0 is a half. So which means when x is 0, y must always be a half. So we'll have 0 squared sine of a half minus a half should give us c. So that will be 0 minus a half equals to c. So which means c is equals to minus a half. So the specific solution is x squared sine of y minus y equals to minus a half. So that is what that question gives us. Lastly, now let's solve. E power y over x minus y over x, e power y over x plus 1 over 1 plus x squared dx plus e power y over x dy equals to 0. Now, we see that m is e power y over x minus y over x, e power y over x plus 1 over 1 plus x squared. N is given by e power y over x. So let's see, what is partial m partial y? So using chain rule on this first term, differentiating this power, we get 1 over x, and then e power y over x. Now using product rule, we get, if we let this to be u, this to be v, so u prime is minus 1 over x, e power y over x, plus v prime u. So v prime u is the same as minus y over x squared, e power y over x. This reduces to minus y over x squared, e power y over x. And this partial n partial x is the same as. So remember, at this point here, this n can be written as e raised power y x power negative 1. So when we differentiate this with respect to x, so this power will give us negative x, a negative, and then if you subtract 1 from the power, you get minus 2, and then times y. And then you multiply by e raised power the same power, y over x. But you see, this is the same as minus y over x power minus 2 is over x power 2, e raised power y over x. So clearly, partial m partial y is the same as minus y over x squared, e power y over x, which is partial n partial y partial x. So the equation is exact. And there exists a function f of x comma y such that m dx plus n dy equals to partial f partial x dx plus partial f partial y dy. So m is the same as partial f partial x, which is the same as e power y over x minus y over x e power y over x plus 1 over 1 plus x squared, and n, which is partial f partial y, is equals to e power y over x. So we call this equation 1, we call this equation 2. So f can be obtained from 1 or 2 by integration. So if I pick 2, so integrating 2 partially with respect, integrating equation 2 with respect to y, we get f of xy is the integral of e raised to power y over x dy. Now, the easiest way to carry out this integration is by substitution. So you can say let u to be y over x. So du is the same as 1 over x dy. So dy is the same as x du. So it will be the integral of e raised power u times x du. And x is not the variable of integration, it's just like a constant. So x integral of e power u du, which is the same as x e power u, which is the same as x e power y over x. So therefore, f of xy will be x e power y over x plus a constant of integration, which is written as g of y. So this is called equation 3. Now, because we are integrating to get this one, now differentiate this new equation with respect to, so remember here we were integrating with respect to y. So the constant of integration now becomes a function of x, not y. So differentiating, three with respect to x, we get partial f partial x equals to, now there we use product rule. So this is u, this b. So u prime is 1 times b is e power y over x plus. I remember when you differentiate this with respect to x, we'll have the power is y x power minus 1. So we'll have to drop and then y and then subtract 2. So which is the same as minus y over x squared. So when I multiply by x, I get now minus y over x. So I get minus y over x e power y over x plus g prime of x. So this is what we call equation 4. But now equation 4 and equation 1 define partial f, partial x. So equation 4 equals to equation 1, since all of them are defining partial f, partial x. So we'll have e power y over x minus y over x e power y over x plus g prime of x equals to, equation 1 is given by e power y over x minus y over x e power y over x plus 1 over 1 plus x squared. So here, we clearly see that this term and this term cancels out. And also, this term and this term cancels out. So which implies g prime of x is 1 over 1 plus x squared. And so to get, if I call this 5, to get the g function, we now integrate with respect to x. Integrate 5 with respect to x to get to get g of x equals to the integral of 1 over x, 1 plus x squared dx. Now, this is a standard integral whose value is tan of x. So g of x is the same as tan of x. Now here you don't tan inverse of x, not tan of x. So remember, you don't have to add a constant of integration to this integral, because at the end of the day, the structure of the function has a constant of integration. So if we call this one as 6, so the implicit solution is f of x, y equals to c, where f of x, y from equation 3 will be given by x e power y over x plus g of y, which is tan inverse, g of x, which is tan inverse of x, so which is c. So the solution is x e power y over x plus tan inverse of x equals to c. So these questions requires you to sharpen your integration skills so that you are able to integrate a function that you find on your way. Thank you.